How's it going, guys? Today we're going to be going over another leak code problem, and today our problem is called walls and gates, and it's a question that's being asked by Facebook.
I get muddy with my buddy. That's my brody. Eat my woody. He got lean. Yeah, he poured.
Okay guys, so today our problem is called walls and gates. It's a problem from Facebook, and our problem description says you're given an n by n 2D grid initialized with these three possible values. -1, which is a wall or an obstacle, 0, which is a gate, or INF, which is infinity, and it means that it's an empty room. And so they just use the maximum value of an integer here to represent infinity, and we can actually assume here it tells us that the distance to a gate is no less than that value. So, sorry, is less than that value. That's guaranteed. So they ask us to fill each empty room with the distance to its nearest gate. And if it's possible to reach a gate, it should be filled with infinity. Why do I keep reversing that? If it's impossible to reach a gate, then we need to fill that cell with an infinity. Okay, so as an example here, if we're given this 2D grid, what we should really be returning here is this grid. And the reason for that is, for example, this cell is one distance away from this gate. Okay, and so these again are just walls, right? These -1s. And so, for example, here, this 2 is 2 cells away from this gate, and this cell is 3 cells away from this gate, and then this is our other gate, right? And so it's not, this cell isn't 2, because, right, this is actually a wall, so we can't go through this cell. So this cell would be 1 cell away from this gate, this cell would be 2 cells away from this gate, so on and so forth. So the grid has successfully been populated with the shortest distance, each cell's shortest distance to a gate, right? So, how do we solve this? I think this is a pretty standard sort of graph problem. I think we could use our traditional graph traversing algorithms like BFS or DFS to solve this. And so the idea here is that we want to iterate through our grid, right? And we care about the gates, right? We want to know how far away any cell is from a gate. And so what we could actually do is we could actually just iterate through this board or whatever board we're given. And every single time that we find a gate, we could just run a DFS. And so what that will do is it'll ensure that from our starting point, we visit every reachable cell from that gate. Okay, and the rest of the problem really just comes down to how do we track that. So what we can do is in our DFS, we can pass a count or a distance variable, and that will just keep track of, okay, this cell is 1 distance away. And then when we traverse to the next cell, we take that distance and add 1. And that really does it, right? So all we have to do is run a DFS from every single gate on the board, and update every cell that we can reach from that gate with a short distance that we've recorded if it's actually better than any previous distance we've found already to that cell, maybe from a different gate. And that's really all the problem boils down to, so let's start writing the code for that. So we definitely have to traverse the entire grid, right? Because we have to get to all the gates. So let's just start getting that boilerplate going. So we're going to iterate through our entire 2D grid called rooms. So we're going to say for int I equals 0, while I is less than rooms.length, I plus plus. And now we're going to iterate through each column, right? So that was for every row, and then we want to iterate through the entire column for each row. So we're going to say for int j equals 0, while j is less than rooms I.length, so the current row that we're on. Now what do we do? Well, we said we only care if it's a gate, right? So we just want to check if the cell that we're on, so rooms ij is equal to a 0, because our 0 is representative of a gate in this example. We said we're just going to run a DFS, right? So we're going to have to write this function, but we'll call it DFS. And when we need to pass are the coordinates we're at, so I and j, and then the distance, right? We want to keep track of the distance we're at in each of our recursive calls. So when we call a DFS on a gate, we're actually at distance 0 to begin with. And then we just want to pass rooms so that we can actually update the grid accordingly. So that takes care of our shell function. Now for the meat of the problem, which is really writing this DFS. So every time we call this DFS, we're going to enter this function, which will say public void DFS. And what do we pass? We pass an integer I, an integer j, an int that we'll just call count, which will basically be our distance. And then we also passed a 2D array, which is our rooms, right? Cool. So the first thing we always want to do in this check is check if we're actually still in the grid that we're given, right? And so if we're not in that grid, we want to make sure that we don't continue traversing. So a quick check for that is we could just say if I is less than 0, so if we got out of bounds above the board, or I is greater than or equal to rooms.length, meaning we've actually gone too far below the board, or j is less than 0, meaning we've gone too far to the left of the board, or j is greater than or equal to rooms I.length, which again is going to be us going too far to the right of the board, right? So going out of that current row that we're on. Or, and this is the interesting part, if we've already found a shorter distance than our current count is at, right? So if we've somehow already visited the cell from a previous gate that we've traversed and ran a DFS on, we don't want to update it with a worse distance or a longer distance to get to the cell. So a quick check for that would just be if rooms of ij is less than count, right? So if the count that we have is greater than whatever the value is in that cell, then we don't really want to update it because it's a worse distance. So if any of these cases are true, we just want to return, right? Because we don't care anymore. We're done. We've either gone out of the grid or we've gone, there's a gate that's closer to the cell that we're currently on. And otherwise, if this if statement doesn't trip, we actually need to record the distance that we have on the cell that we're on, right? Or in the cell that we're on. So we just say rooms of ij is equal to our count. So again, that's just setting the distance. We're saying, okay, it takes 5 or 2 or 3 distance to get to the cell that we're on from whatever gate we're calling a DFS on. And then after we've set that distance, all we need to do is try and traverse the neighboring cells of the current cell, right? So we're just going to say DFS of I plus 1, which is going 1 row down, j, and then we want to say count plus 1 because we're actually going to take 1 step to get there, and then pass the rooms, and then we're going to do the exact same thing but traverse the other directions, right? So that would be DFS of I minus 1 j, count plus 1, rooms, DFS of I j plus 1, count plus 1, rooms, and then finally DFS of I j minus 1, count plus 1, and rooms. And again, these four recursive calls here are really just to traverse the neighbors of whatever cell we might be on at any instance. And so once we've actually iterated through this entire board, and every single time we've seen a gate, we've ran a DFS, we will have successfully updated the board and each of the cells in the board to reflect their shortest distances to whatever gate they might be closest to. So let's run this code and make sure that it works. Awesome, and it does. So guys, that's how to solve walls and gates in Java. Again, this is a question that's being asked by Facebook. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more, and I'll see you guys next time.
I get muddy with my buddy. That's my brody, he my woody. He got lean, yeah, he pour it. And we riding in the forest. Yeah, yo bitch, yeah, she born.